And then I looked at the time and saw, holy smokes, we've once again.
There's no hour mark in the rabbit hole.
Oh, there we go. There we go. A classic podcast gold from Marshall Lochbaum. There's no hour mark in the rabbit hole. Welcome to episode 83 of ArrayCast. I'm your host, Connor, and today with us we have three panelists and a guest who we will get to introducing in a couple moments. But first, we're going to go around and do brief introductions. We'll start with Bob, then go to Adam, and then finish with Marshall.
I'm Bob Terrio, and I am a J enthusiast, and I forgot to introduce myself on the last show, even though I was hosting, so now I'm making up for it. I'm introducing myself again. I'm Bob Terrio, J enthusiast.
I'm Adam Botsevsky. I am a full-time APL programmer.
I'm Marshall Lochbaum. I've worked with J and APL in the past. I created BQN, and I'm a Singeli enthusiast.
And as mentioned before, my name is Connor, Array language enthusiast, love all the Array languages, and host of today's episode. I will say I listened to the last episode. It was fantastic. It's always a treat getting to listen to an ArrayCast episode that you haven't already been a part of. And we're going to actually depart from what we usually do and briefly introduce our guest for today. His name is Jay Bates, and he is the creator of the Jam programming language, which is a fork of the Jelly programming language, which is what is going to be the primary topic of today. But the reason we are introducing him up front is that we have incredibly sad news to announce, and I think we're going to throw it to Marshall first, and then we're going to have some thoughts to share on the incredibly sad news.
Today we're talking about a true Array language enthusiast. This is Raghu Ranganathan, who is probably better known by the handle RaiseTime that he used everywhere. And just a few days ago, Raghu's father got in contact with some people in the Array community to tell us that, in fact, he'd gotten caught in a riptide in the ocean and had drowned at the age of 22. So, I mean, we're all, of course, very sad to hear this. Raghu touched everyone in the community. I can say for my own part that I got to know him when he was working with BQN. He contributed, all sorts of support for the language. He did what's on the website now, the help pages you can see if you click on a primitive and ask for help. He wrote all those pages. He did VS Code support for BQN. So he's done a lot for me. And what I can also say is that this is not really my story. This is everyone's story in the Array community, because Raghu just did so much for all of us. If there was a new language, he was immediately interested in trying it out and seeing what it was about. He was interested in helping other people to try it out. So he was a huge figure in the community, and we're really going to feel his loss.
Yeah, I'm. It's definitely a loss for me too. I teach a lot of people APL, and I taught RaiseTime or Raghu APL as well back in 2020. He just stopped by in the APL chat room on Stack Exchange, and I asked him, as I usually do with people who drop in if they're interested in APL, and ended up teaching me APL, which probably was his first APL array language. And from there, he became an integral part of the array community. Made several tools to facilitate using APL and many other array languages, and even did a paid project for Dialog. So he's not just an array programmer enthusiast, but actually did real work as well.
Like Adam, I first met RaiseTime through Stack Exchange. Unfortunately, I only knew him through Stack Exchange, but he helped me write the wiki for one of my languages that I've created. He contributed to a language that's close to my heart and the docs for that. He was always a lovely person to just hang out with in the 19th Byte, if you're familiar with that, and was just a pleasure to spend time with, even if it was remote and through an avatar rather than in any in-person way.
And my interaction with Raghu, I had a chance to chat with him a number of times on Zoom. But because we were doing the JWiki at the same time, he was coming on. The thing is, when he came on, we realized, because I'm on the other side of the planet from him, he was getting up at 4 a.m. to attend some of our meetings, which is, I mean, it just shows you what he was doing. And I think, I mean, beyond the sense of loss that his family must be feeling, and I can only imagine, it's the sense of what maybe could have been. He was only 22. A lot of times we're talking about people who are in their 60s or 70s or 80s that are passing away, have been able to, over their lives, make a huge contribution. But in the case of Raghu, it's kind of, aside from the loss that we all feel for what a wonderful person he was, because I want to emphasize that, is what he was going to be doing. He had so much potential, and unfortunately, we're not going to be able to be the beneficiaries of that potential.
And I do think, since we have no representative of the K community here, I should highlight that, the K Wiki is such a great resource for K programmers, and he's also done an introduction to working with NGNK, which the creator isn't specialized so much in documentation, which I sympathize with, because the reason he wrote my help pages is that I didn't feel that was something I could do very well. So K was really a big thing for him lately, and I think he's helped a lot of people, help make that more accessible to people who want to try it out.
It's not just K.
Oh, and yeah, this is by no means an exhaustive list. We've listed all the major programming languages, because the minor ones would fill an episode.
Now we another fairly prominent one is Niall, which I think he also contributed to the documentation of website of.
It's just incredibly sad. And yeah.
I think the thing that I often take away from this is we're not here for a long time. So appreciate the people you're around, because it can happen very quickly. And our thoughts are certainly with his family, because they'll be impacted by this for a long, long time.
We should express our appreciation for his father reaching out and telling us about this. I could immediately after it happens, it requires something to be able to go and say. So his father must have opened up his email and looked at what were the latest communications he had, and then determined those would be the ones to reach out to say to tell these news. So several of us received emails separately and in threads that have been recently there.
Yeah, I hope that if I'm sure we will try and send this episode to his family and they listen to this. I hope it's clear how profound an impact that Raghu has had on the array language community. I mean, I'm a bit in shock, because I found this out less than 30 minutes before recording this, and over the last couple months, I think I've mentioned on this podcast that I've been going through some of the code.golf problems, and Raise Time, the handle that Raghu went by, is on so many of the problems that I'm solving. And K is one of the languages, specifically NGNK, that website uses. And I've been referencing that NGNK tutorial, every single time I was working on it. And I think there are a few names and aliases that if you start falling in love with the array languages, you almost immediately stumble upon, since I discovered the array languages in late 2019. And whether it's during Advent of Code, when you start trying to learn a new array language, or you're just, trying to build some small thing, you always run into these handles, and it's at such a young age for someone that clearly has so much passion. Yeah, I hope his family knows that this community is thinking about them, and he had a profound positive impact on the communities that he participated in, even for the folks that never met him in person. Yeah, I'm not sure if there's anything else we want to say before we try to transition to.
Well, I think he would probably be upset that we would spend this much time out of an episode talking about him, because I think he would want us talking about the array languages. But yeah, it certainly changed the way my weekend flowed.
Yeah. So yeah, I guess, yeah, finally we'll just say, yeah, friends, family, anyone that's listening to this, know we're thinking about you. And I think this is all a pretty big shock and very sad news. But yeah, with that, I think we will try to transition to fully introducing today's guest after that sad news. And as mentioned before, today's guest is Jay Bates, who I primarily know as the creator of a programming language called Jam, which is a fork of the programming language Jelly, which is a language that I have fallen in love with over the last... I can't remember actually the first time I really started diving into it. It came from a comment from Adam saying that, like, oh, you know, you love tacit programming, you really need to look at Jelly. And... Jelly is an incredibly confusing language with minimal docs. And so I ended up building a tool called Jello to kind of decipher it. And we've been trying to look for someone to talk about the Jelly programming language because we haven't really dived into it in detail in this podcast. And Jay's name came up because you've done a lot of work with Jelly and have actually forked that and created this language called Jam, which we'll definitely throw in the show notes. There's a great wiki which enumerates all the differences, which I think we'll talk a little bit about today. But on top of that, you're also one of the moderators for the Code Golf Stack Exchange. And you go by, so some folks may be like, oh, I don't know who this Jay individual is, but you might know him by his alias. And hopefully I'm going to pronounce this correctly. It's Caird Coing Herring Ahing, which maybe is a great place to start. Do you want to, I guess briefly introduce yourself? Or if you want, you can go back to, when you started getting into programming and then take us to the alias. Or you can even start off with explaining the alias and we'll go from there.
Well, the alias is originated in Jelly. So it might be better for me to start with how I got into Jelly and then go from there. Because I was introduced to Code Golf. At that time, it was only the Stack Exchange site. There weren't really any bigger other sites to do Code Golf on. By a friend in, first year of my secondary school education, when I was still learning beginner Python. And I wasn't very good at Code Golf at the time because, of course, I wasn't very good at programming at the time. And after about a year or so, just sort of puttering about the site, getting better at programming in general and Code Golf specifically, I noticed that another user was teaching Jelly to another one of the current moderators on the site called Hyperneutrino. It looked like a cool language. I was like, oh, if you're teaching Hyper, could you teach me as well? So there is I believe it's now, long frozen, potentially deleted chat room on the Stack Exchange site where you can go back for years seeing my progress learning Jelly, learning how to golf in it, and how to actually, use the language. And I think that must have been nigh on 8 years now. It became the language that I use on Code Golf. I believe I'm nearing on 1,000 answers on Code Golf, and at least 80% of them have to be in Jelly. And unfortunately, my username doesn't come from any one of my answers. Instead, it comes from an answer by the creator of the language, Dennis, who wrote a brilliant Jelly program that uses its built-in string compression to complete the specific task. The task was write a program that outputs programming puzzles, and then when you remove all white space, it outputs Code Golf. The specific Jelly answer used the string decompression and then to create two strings, and then took the maximum lexicographically of those two. With whitespace, the two strings were programming puzzles and Caird Coing Herring Ahing, and without it was Code Golf and another string that I can't remember. And I figured It's an answer written in Jelly. It's referencing the site that I primarily use Jelly on, and I don't have a good distinctive username. That's a pretty distinctive username, so I'll take that. And that must have been 6 or 7 years ago, and I've been Caird Cohen Herring Ahing ever since then.
We should mention for the listener that if they can't find a Code Golf site that's called Programming Puzzles and Code Golf, that's because the site changed name since then. But at the time, that was the site name.
Yes. In fact, I have just gone back to that answer, and in the comments underneath it, there is a comment from Raise Time saying where it all started, clearly made after I became a name within on this site. And I honestly forgot that was Raise Time who, I don't know, brought attention back to that.
He's still with us.
So that's serendipitous, I suppose. I forgot about that. There's also a full write-up of what I said and the explanation behind the answer or behind the username on the Stack Exchange, on the Code Golf Stack Exchange, as well as explanations for a couple of other usernames that I had, which are based on that as well. Because I don't know, it's stuck like that, and it's distinctive, and I like it.
So just to clarify, and we will include show notes in the show notes, links to a couple of these different Code Golf sites, or not Code Golf sites, specifically these problems. But one of them is the From Programming Puzzles to Code Golf, which reads, what you said basically at the beginning. When you output the execution of your program, you get programming puzzles, the string. So double quote, programming space puzzles, and double quote. But then if you remove all spaces, tabs, and new lines, it then outputs the string Code Golf. So that's the problem you're trying to solve. And then there's a couple of Python solutions at the top that make it pretty clear what it's doing. But can you explain the jelly code again? That somehow Caird Cohen Herring Ahing leads to Code Golf?
Yes, I can. Jelly has a very clever string compression built in that I've actually written up a full dissection of how it works on a different post on Code Golf. But basically, it has base 255 represented by each character in its code page, turns that into a number within the string delimiter, and then breaks down that number by repeatedly div modding it. And based on the results of the div mods and based on the results of the divisions and the mods, it picks and chooses words from dictionaries that it stores within the language. And then just smashes these words together to come out with what the specific thing. So in this specific answer, it has the string opening delimiter once at the start and once in the middle. This creates two strings as an array, so that you don't have to write two strings and juxtapose them instead. And the first one looks like gibberish, but through this decompression, it comes out as programming puzzles. And the second one also looks like gibberish, but importantly, it has a space second from the last character. With that space, that gibberish decompresses to my username. Without that space, it decompresses to Code Golf.
Oh.
And then there's a little trick at the end to make sure it's choosing which one is the correct one of those two strings.
Maybe we want to back up and give some context. If the listeners, perhaps some of them out there, are not familiar with Code Golf, the idea of Code Golf is just that you have a problem and you want to solve it in the fewest characters possible. So perhaps now it clicks why Jelly would have this crazy scheme for writing ordinary readable words in less readable but very tiny strings. So the analogy there is that, in golf, you're trying to get to the hole with the fewest strokes. In Code Golf, you try to solve the problem with the fewest characters.
And if you're the listener, you're Alice and the white rabbit just went by, you're going into the rabbit hole.
Yes, and one thing about Jelly for Code Golf is it's specifically designed to be good at Code Golf, well, as good as Code Golf as possible to be. Which that whole side of designing code golfing languages is a whole other rabbit hole to go down. But Jelly was one of the revolutionary ones back in 2016 when it first came onto the scene, and because it makes use of a custom code page where it can use all 256 bytes instead of just limiting itself to ASCII, which is why they look even more like gibberish than standard code golf programs do.
Before we dive straight into Jelly and to Jam, is there more you want to say about your back? Because that was an explanation of your username. But if you want to give a little bit more of your background, because it is one must take a very the less traveled path, something like that. Robert Frost. I think is that the right guy? I'm looking at Bob.
I think so. Yeah, I think it's the path less traveled. Yeah,
the path less traveled. Array languages, I'm fantastic at quoting some guy that wrote a poem. Not as good. But yes, your path that you traveled was probably one taken by few. So I'm interested to hear how you ended up, falling in love with Jelly ultimately and code golfing.
I mean, code golf in general, it just scratches the itch in my brain of, I mean, there's the classic trying to solve a puzzle, and trying to solve a programming puzzle is so fulfilling to do when you actually do it. And we all know that from debugging code to finally cracking that solution to anything involving programming, really. For me, the clear objective goal of shortest possible program just made it so much more, oh, I have to try this. Because you think you have the shortest, and then you dream up a way to save a single byte, and that is genuinely an example. I have dreamt a way to save a byte in one of my Jelly programs before, and it works, and it's completely weird, and it twisted around, but you've saved the byte, and that's that you've looked at it from a new perspective, and you get to improve it, and yeah, it just scratches all of the brain itches so well for me that I just love it. And for Jelly specifically, I started learning it, and it felt even more satisfying to solve these problems with Jelly than with Python. The tacit programming based around it, the array structure that it uses, just felt so new to me, and I'd never seen them before. This was before I'd heard of APL or really any array languages. And it felt new, it felt innovative, and it just felt...
So Jelly was actually your first exposure to an array language.
Yeah.
Interesting. I wonder how many folks can say that. I guess probably a few in the code golf community.
Yeah. Jelly is what introduced me to APL.
So you come into APL and you say, what a weird language. It's so verbose yet comprehensible.
Yeah. Well, I mean, there's the famous thing of people who haven't seen APL before go, did you know that you can write Game of Life in a single line in APL? And it's this meme and everything. And I've written an Enigma machine in 36 bytes of Jelly. So it's one of those things where, yeah, APL is just, it's long, it's verbose, it's clunky.
We gotta get this guy a marketing contract. So what you said that Jelly came onto the scene 2016, and there was a bunch of languages coming on, but Jelly was, I think in your words, you used revolutionary. What was it about Jelly that made it so revolutionary for code golfing?
Up until that point, code golf languages almost always used a stack-based structure. Push onto the stack, pop it off, do an operation, that kind of stuff. And manipulating the stack lost a lot of bytes in sorting out these programs. The big language before Jelly was called CJAM, and when you look at an explanation, there's so many which is like rotate the top 3 elements of the stack to get them in the right order for the arguments. And Jelly went, nope, we're going to make it tacit. No stack, just make it tacit, passing it through, and so saved a good chunk of bytes just on manipulating the arguments around, and not having to push and pop in the right order and make it clunky and that kind of stuff. And then just using a lot of tricks that, I mean, we're all familiar with array languages, things folding, like folding a list by some, I would use the term dyad, but like a operator that takes two arguments. A lot of a lot of old languages, the way that they would do that is they would write a function, push it onto the stack, pop the function, and fold by that. Whereas Jelly uses a system called Quix, which I think, Adam, what's the APL equivalent of a Jelly Quick?
It's an operator.
Operator, yeah, where it's just similar to an array language. You just have the command that you're folding by with the fold operator, quick, insert your name for it here, and it just
It's not a coincidence, right? It says in then this is
Adverb
yeah,
modifier.
or adverb slash conjunction. It says in Dennis's description of
yeah.
Jelly that it's inspired by J, and you literally use plus slash for summation, just like APL and you can sum using plus slash, just like in APL and J. There's a shorter way to do it.
Because it's code golf. It's all about getting the shorter ways of doing it. But yeah, so it's inspired by J. It's very similar to that, and we all know how compact and short you can get tacit array-based stuff. And when you apply a code golf mentality to designing a language like that, it makes it a lot harder for stack-based languages to keep up.
And so I guess my next question is, because when I started looking into Jelly, as I mentioned, or at least I'm not sure, you can clarify if there's a hidden book on how to program in Jelly. But when I kind of went to the repo, there was some documentation, but it was pretty light, and I was very confused by the tacit model, because it's inspired by J, but it's also vastly different. A lot due to the fact that you don't have overloaded characters or symbols, right? Most of them are either monads or dyads, and
yes,
and then because of that, you get the interesting tacit model. So, for most folks that stumble across Jelly one way or another, was it through the Stack Exchange that most would learn it, or like what? How do people become Jelly experts like yourself in the past?
As far as I'm aware, I've never seen Jelly in a context outside of Code Golf. So it will be through a Code Golf site. Stack Exchange at the time happened to be the biggest one when I joined and started learning Jelly, so that's how I learned it. I think Code.golf allows Jelly.
I don't think it does at the moment.
No.
Right now, I think J and K are the two array languages that.
There's one Code Golf language with a set list that has Jelly.
The weak golf, I think, has.
Yeah, it doesn't leave. It hasn't left yet the Code Golf space. So it's one of those things where you stumble across it on one of these sites and you go, what on earth is this very short, incomprehensible squiggle of letters and symbols? And then hopefully the person who posted it has posted an answer, an explanation. I always try and include explanations in my Jelly answers, just because when I was learning, I wanted to know how it works. So anyone else who's learning, they'll probably want to know how it works as well. Which is one of the things I do like about the Stack Exchange system, is that you can add in explanations and breakdowns of your code, which I don't know if a lot of other sites allow.
Yeah, well, it's not even so much scored on the number of characters you have as the visibility of somebody's answer will be based on people upvoting the answer, which is just personal opinions.
Yeah, and I have lots and lots of words to say about that system, but that's not what we're here to discuss. But I guess adding in an explanation can only help that. Yeah.
But it does mean that, people will more readily see the answers that are clearly explained, and So you have more emphasis on how something's done instead of just here it is, here's the code.
It's a popularity contest, essentially.
Yes.
Always, because I mean, yes, there's a winner, the shortest code, if you want to do that, or winner per language. But as for the upvotes, it goes on what's popular to upvote. That also means that things that look unusual, or and somehow is a funny type of answer, unusual type of answer, answered in some language that you wouldn't normally use for code golf, those kind of things, they also get a lot of attention. Or if somehow the name of the programming language you use ties in with the problem, then you'll get loads of upvotes.
Yeah, I mean, my most upvoted answer on the site is a 3-byte jelly answer, which, given a non-negative number, output it if it's even, otherwise error if it's odd.
3 bytes?
And you can do that in 3 bytes in jelly, yeah. Because of one of the built-ins doesn't work on numbers, and then you just run that built-in equal a number of times equal to the parity of the input.
Yeah, so the issue is that like erroring isn't a normal way to use the language really, so that's the difficulty. That's why it takes so much code.
Yes, exactly.
Right now, I love the playfulness of the language.
Yes.
Like I don't know jelly, but just hearing you describe it and use it in code golf and the way it makes you think about a number of different solutions to a particular question, that's the kind of thing that I think is really attractive to a lot of these languages. And I that's the joy I get from it. Now, what I hate to do, because I think I'm the oldest on this particular panel, is there anything practical about it? Are there things people are learning out of doing this kind of compression? Is there something, because it's so narrowly defined, often you get things that sort of spring from that. Is there anything that's coming out of that?
I am aware of one practical use of jelly, which is when I used it in one of my jobs. Because I found it easier to write up a quick program to do something in Jelly than in Python. But as far as I'm aware, there hasn't really been any practical exploration of Jelly in specific, or like golfing compression, for example, as a whole. As I mentioned before, there is sort of the ongoing development of making languages that can be better at code golf. And Jelly is unfortunately falling behind because it hasn't been updated in 6 or 7 years now. So there are newer languages coming on the scene that have 10, 15 years of experience that they can look back at and go, how can I improve? And so coming out with shorter Jelly. And sooner or later, there's got to be a limit. And I guess it's only more and more development of this is going to result in that limit. So,
well, now hold on. Having a limit and reaching the limit are very different things. But eventually, progress will slow, I suppose.
Yeah,
it'll only become perceptible to the people that are, really very closely involved in this.
True. I mean, there's some like new age golfing languages that are using fractional byte counts, which is only possible in theory and never in practice. But if you want to squeeze 1/8 of a byte out of your out of your program, so that in theory it is shorter than another one, but at that point it's splitting hairs. But that's exactly what the limit tends to, right?
Without going down another rabbit hole entirely, while we're down a rabbit hole, I am curious if you can give a like high level. You're saying it's 6 or 7 years, sort of falling behind. At a high level, if our listeners are interested in these kind of newer, not sure if they're also revolutionary, but it seems like you're familiar with them. Can you throw out the names, and if it's possible to give like a 5 to 10 word summary of the big thing that is added? Because I am curious as to what languages there are out there that I haven't heard of yet.
I think the biggest one right now, at least in CoGolf, is Vixal, spelled Vyxal. Although the creator of this is going to be very annoyed at me because he insists it's pronounced Vixal, if I remember correctly. But actually, Raisetime contributed quite a lot to the development of Vixal and making it better than Jelly. I think the primary thing it has going for it is that it has all of these previous languages that it can look at and just improve so much on there, where they have redundancies and where they're missing areas. and it does it very well. That's the big one. And then there's all sorts of esoteric languages that you'll see thrown out on these CodeGolf sites with a bunch of assorted, confusing built-ins and letters that just happen to be really short for these subset of problems. I could go onto the site right now and find 10 of them if I wanted to list them all off. But yeah.
Well, maybe we'll dive in. Well, maybe we'll have you back at a future episode, and we can further learn about that stuff. So I realize we haven't actually really given like an overview of Jelly per se. We've talked about, its evolved tacit model, monads, dyads. But maybe before we start talking in more detail about the tacit model and what makes it different, maybe let's take a step back and just in case there's a listener that's like, what? I haven't even gotten a full description other than it's a code golfing language that's really good at it. What is Jelly as sort of a programming language, and then we'll go from there.
It is very similar to a lot of the classic array languages because it's inspired by them. A Jelly program takes a left argument and maybe a right argument. It chops off commands at the start. It applies those commands based on patterns to the left argument and then maybe the right argument, passes that value on to the next one, does it again until the entire program's just complete. That's more or less exactly that. Yeah, that's exactly how it works. If that answers your question, or
no, I mean it does for me. I've spent a lot of time with Jelly, and I guess to further delineate it from existing array languages. So J uses ASCII symbols. BQN APL uses Unicode symbols. What is it fair to say that Jelly uses? I guess we mentioned the code page.
Yeah. So Jelly's code page is actually. It makes sense. It's not like a bunch of random symbols taken from Unicode and thrown together. It's primarily letters, just the standard ASCII letters, then those letters with a dot over the top, those letters with a dot underneath them, and those letters with like a hook on them. They're taken from various different languages and scripts and actual languages and scripts and put together into this one thing. But the use of the letters and the overdots and the underdots is very intuitive. For example, if the uppercase B character turns it to binary, takes an input, outputs it in binary, B with an underdot undoes that. So it takes in a list and converts it from binary. So it's very intuitive. If you know what one command does, you can kind of guess what a bunch of related ones are going to do.
I could say about those characters that while it's an attempt to make meaningful pairings between characters and what they do, and the overarching rule is that the characters must be directly typable from the US International Keyboard layout.
Yes.
So that was like the restriction. It's not Unicode, it's US International Keyboard.
I always forget that one because I do not have a US International Keyboard.
Yeah, and it is very, one of the comments I'd make on Jelly is that it has just a ton of primitives. That's also one of the big differences is even compared to J, it's got more. So, one of my favorite ones that comes up all the time that is not spellable succinctly in J, APL, or BQN is half. Usually that's either 2 divide with a,
J has half, though. It's minus colon.
Really?
Yep.
Gonna need another example.
Okay. Well, I did not know that J had half, but I think it's.
But J's version is 2 characters.
Yeah, that's true. Whereas in Jelly, I think it's capital H, and then I think H underdot then is probably double.
Yep, H for half.
And for J, it's plus colon for double.
I did not know that J had those. So okay, that's I guess something that Jelly just borrowed from J.
I think you have increment and decrement in Jelly, which you don't have in J.
I think it has that as well, doesn't it?
Increment and decrement are greater than colon
Wait, what?
and less than colon in J.
Yep.
Oh yeah, you do. Okay.
J has a lot of primitives.
We're failing at this.
It's supposed to be a Jelly episode, but we'll call it In Defense of J.
Well, the thing is, J's primitives are also, so it's only got like 100 and something primitive glyphs or digraphs or whatever they're called, but they're ambivalent. So most of them has at least 2 meanings, and some of the modifiers have like 4 or 5 or 6.
Yeah.
Which I might actually point that out as an advantage of Jelly, in that if you see the character, you know what it does, period.
Yeah, it's much easier to read in that way.
And Jelly does currently have, of the 256 characters in its code page, let me double check. I believe it's 23 of them are currently not assigned as single character things. So it has 233 single character primitives.
Well, and so it doesn't have variables at all, right? So there are no,
It has one register,
yeah.
but generally speaking, you don't use it.
So there's one variable.
Yes.
But yeah, it doesn't need identifier characters.
And then it uses 5 characters as prefixes to like shift the character set so that you can put any one of the other 200 and something, whatever characters after those and get additional meanings. So it's not just 255 or whatever mine is.
I think it comes out at around about 400 individual commands or primitives, all of them 1 or 2 bytes long.
So when you run a Jelly program, it's interpreted, right? Is there how large is the code that's required to interpret it?
I can find out. I think I have the interpreter, or at least the original one, not my fork of it, is 3,000 lines of code. And that's just the interpreter. That's not counting the dictionary and a utility, a very short utility file.
Because I'm just thinking, in a practical case, if you can reduce the amount of bytes in your program, although if it needs to be interpreted and you need the dictionary, it's going to be much larger than that. But for a large program, you could actually reduce the size of, like for Internet of Things or stuff like that. Within a certain space, you could put a lot more code in. I mean, that would be a practical approach.
Jelly is released as a Python module. If you download it, you can do import Jelly into Python and just run a Jelly program in a Python thing by doing jelly.interpret, and then you give it the code. So in theory, you could do it that way. But yeah, you could absolutely compress down the or like try and shorten the interpreter, maybe even compile it into something. That's not really anything I know much about, if I'm being honest.
I'm just wondering whether anybody's thought about using that, because that would be, again, I hate to be practical with something that I think is so playful, but if you can reduce the size of your program by that much, there are places that would make a big difference.
Yeah, and because it's done with a code page, you look at it and it's these incomprehensible strings of characters, but they are, at the end of the day, they're just bytes. So you can do it with any series of characters to represent each byte that you want. So you can throw it into some machine code style thing. If you can translate those bytes down really low level, I guess that would be a very, very interesting thing to see.
All right, so I think now it is time for Tacit episode 5.5, which comes right on the heels, I believe, of Tacit episode 6, for a little spoiler for the listener that's made it this long in our podcast. So I think one of the most interesting aspects of Jelly is the tacit model that it introduces, which I have not seen a tacit model in any other language that is similar to the one that Jelly has. And it's incredibly powerful. It's arguable whether it's practical, because it, I think, requires both the writer and the reader of the code to understand the tacit model. But I think it's definitely would be interesting to chat about it. So I guess in your own words, how would you describe it, and what was it like learning it? And I'm not sure if we want to get into that much detail, but of like describing links, chains, and multi-chains, because like that stuff I still fully haven't like wrapped my head around. And most of the time when I'm typing in Jello to program in Jelly, I will like test it out, and then I'm like, I know it's one of these ways because I'm creating technically, I don't know if it's a chain or a multi-chain. And it's like, at the end of the day, I get it to work. And then actually 5% of the time, there'll be some problem where I kind of, I need the Weewa stack model of like, I need to save this thing here because I need it in like 3, operations. But I don't know how to carry that state along in order to the time where I need, that state plus the current result that I'm at. So anyways, after that little monologue, I'll throw it over to you to describe, Jelly's tacit model, and we'll go from there.
You mentioned how difficult was it to learn? That's the hardest thing to learn in Jelly. what all the commands do, there's a massive table of them. You just scroll through them and you find it. How on earth am I arranging my program to make the patterns work? A question I was asking myself every single time I was writing a Jelly program for the good 3 years when I first started. And even now, I'll turn around to someone else who knows Jelly just as well as I do and go, why is it working this way? Shouldn't the pattern be this? And then go, oh no, wait, hang on, no, the pattern's actually this, and it's complicated and confusing. Because the way that it works is that it, as I said before, it chops off the first few commands and then runs those, and then does that again. It chops off the ones that start and then runs them and keeps going. The way it decides which ones to chop off are based on how many arguments each of the commands takes, whether it's 0, 1, or 2, which is why Jelly, unlike J, has fixed arity on every single command, because it directly affects how the program is passed. So you can't really have like variadic programs or commands because it means a completely different thing. I won't go into what those patterns are, but it's basically, do I have you might have, say, plus and H next to each other, so adding half. That's a 2-1 pattern. It means you throw the one argument on one argument and then add them together. You half something and then add them. So let's say that you were given the one argument of 5 for that. You'd half the 5 and then add it to get 7.5. Makes sense.
Which,
right?
For the combinatorial logic enthusiasts, is the S combinator. It's the hook.
Yeah. But if you gave it 2 arguments instead of 1, it doesn't do that anymore. It adds the 2 arguments together and then halves the sum, because the pattern is different, because it has different numbers because it has a different number of arguments provided to the entire program. But the arity's always the same, if that makes sense.
It does.
This is genuinely the most complicated bit about Jelly. It's also the elegance in the language is these patterns. And when you get... So Jelly is broken down to atoms, which are the individual commands. Each one is an atom. Makes sense. It's the most fundamental building block of the program. You combine atoms into links, like you mentioned, and then you combine links into chains. And the elegance of Jelly is that the patterns that you use in atoms in links is the same patterns that you use with links in chains. In that, I'm trying to call on a APL or a K like comparison. APL, you can, yeah.
I think you can say that you can combine functions with or modify functions with operators deriving new functions, and these derived functions can then be in trains, for example, to create whole programs.
Yes.
It's not exactly the same, but it's kind of that direction.
Yeah, it's you build up the program using the same building blocks, whether you're looking at it at the extremely low level or you're doing this super convoluted one that requires chaining chains together into a multi-chain, and there it's still the same patterns. So once you learn the patterns, you've learnt the language, which is why I think it's incredibly complex and yet simply elegant in like how a Jelly program just sort of is broken up and run.
Yeah, I completely agree with the elegance part. I mean, like I mentioned, is it practical? Is another question that I'm not really interested in answering. but it does. I mean, I've kind of come to referring to the tacit model as like arity pattern matching.
Yep, that's exactly it.
It looks at the arity of the fixed arity functions, and I think actually, so once or twice on this episode, I tried to correct something I said in Tacit Talk when I would think I was talking with Kai. And then like I got into correcting myself like I am right now, and then like never actually corrected myself. And the thing that I said was that like APL and BQN, it was possible to do this overloading on the arity of the functions, which is what in WeWa it does with a couple different operations like partition. If you give it a unary function versus a binary function, it does different things. And I said, I think that's possible in BQN or APL. And that was incredible. Like it was a throwaway comment, but it was incredibly incorrect. And it's like, I think very important to correct that I was wrong, because It is the fixed arity that makes this kind of thing possible. You can absolutely not do this kind of thing in APL and BQN because of the ambivalence of the functions. If you aren't able to say, is this a unary function or is this a binary function, how could you possibly dispatch on the arity of that thing? Because it's got multiple arities, and it's depending on how you call it, which is, I think, like an important thing noting when you kind of contrast these languages, because you're able to do things in Weiwa that you can't. And then also in Jelly, you're able, like, the ability to do this arity pattern matching elegant thing. It hinges on the fixed arity of this stuff. Adam's got something to add to this, or to rebut. One of the two.
Well, it's actually two things, both adding something and rebutting something. And the addition is that even K can do this kind of thing. Those flavors of K that can have a monadic marker, a colon after a primitive, they can choose based on whether an operand takes a monadic or dyadic, whether an operator takes a monadic or dyadic operand. That's the addition. The rebuttal is that you could, I'm not saying you should, I'll actually say you shouldn't, but you could pass in your monadic function bound in such a way that the derived function cannot be applied dyadically, right? So so at least in dialog APL, if you bind the left argument to a function or a right argument to a function, then it cannot be applied dyadically to get a syntax error saying this function cannot take the left argument. And you could have an operator analyze what it has gotten to derive the intention of the user. Say if you're giving me a function that surely cannot be called dyadically, you must mean the monadic meaning of this. And otherwise, dyadic.
Yeah, but then you rely on the user to pass in something that has a form that's known to the analyzer, and most functions that you
just like using the colon in K to indicate whether you want monadic or dyadic form. But
but K is a totally different mechanism. So K,
Marshall, I said you shouldn't. Don't do this. Okay, just don't. I'm just saying you could.
I don't think it's really the same thing. Like K semantics, I think there's a little wiggliness. I haven't sorted this out really, but in general, the semantics are that a function has a specific arity. However, and this depends on the K version, the arity of every function is decided syntactically, statically before the program is run. So that's what the colon does for you. It's kind of choosing between. In cases where you can't, where the syntax doesn't tell you, you choose either, I want the dyadic plus or I want the monadic plus. But once you actually get to run the program, every function has been given an arity. In APL and BQN, what you have instead is any function at all, you can choose to either call it with one argument or two arguments. And that's just something that the language gives you. Now, it may error in one of those cases, but there's not really such a concept as an inherently monadic or dyadic function. It's just, this is something that we might choose to call a function that errors in one of those cases.
And Jelly does actually have three quicks that you can apply to monads and dyads to turn them into dyads and monads, which can completely change the parsing. But the way that they work is that the quick is just attached to its atom to make one other atom, or make a link, and that link has the arity decided at the start of the program before anything happens. If you use a dyad with a backtick, which turns it into a monad, it's always going to be a monad. And if you use the left and right braces on a monad, it's always going to be a dyad, no matter what. So the arities can get changed with these specific commands, but the arities are still fixed, if that makes sense. There's no way of changing them mid-program, after writing, or anything like that. And so the pattern matching is still sound and makes sense.
That was one of the comments I was trying to make, was that it's an incredibly elegant, if not entirely practical, but it makes me wonder, like, it hasn't been explored, I don't think, like this kind of arity pattern matching tacit programming in any other programming language that I know. And I wonder if there is a simplified version of this, like this, the goal of this tacit model was code golfing. It's, cram as many patterns as possible so I don't need to do
Yeah.
extra things to get the, order of operations of my atoms evaluated. I don't have to add extra stuff. But, there's a lot of really nice things that fall out of the arity pattern matching. One of them is just unary function composition. It's one of the things that it saddens my heart in BQN and APL is that when you're trying to do tacit code and you just have a bunch of unary functions, you end up having to do parentheses or the breaks, or in J, the cap, in order to get, unary function composition. But in the Jelly model, and I assume all of this applies to Jam as well. I'm not sure if you've made any changes in the tacit model there, but it's just when you see a 1-1, that's just unary function composition. And that kind of yields you another unary function. So this series of fixed arity functions that are all 1, 1, 1, 1, 1 is just, you're just applying unary functions. And it's really, really nice. And, sometimes you end up doing a bunch of stuff that you get this hierarchy of, if you do the equivalent of the, what do you call them? The train trees in APL, to kind of visualize what it's doing. It's crazy. But I wonder if there's like a simple, a simplified arity pattern matching model that could be used in kind of like a general programming language, and it'd be quite nice.
There is. I've actually written, as a exercise for a CoGolf question, I came up with Gelatin,
Ooh.
a programming language which is an incredibly simplified version of Jelly with very simplified pattern matching. Because the intent is write an interpreter for Gelatin and do it this way. But it simplifies down this pattern matching into a way which is a lot more digestible than going into the Jelly interpreter and seeing how it breaks down all of the patterns, which, by the way, I did do when learning these patterns. I went into the code and taught myself what each one meant because that was the easiest way that I could figure it out. But yeah, I have also, as a bit of an exercise, and I never finished it, but I messed around with a language that I called Hatred, because it does, because the intent is, again, this arity pattern matching in the least intuitive ways possible, just as an exercise, because Jelly's patterns are also incredibly intuitive. If you are interested in combinatory logic, they make sense in the same way that a lot of the combinators there just go, well, yeah, of course it would do it in this order. How else would it do it? For example, if you have 3 dyads in a row in Jelly, and it's given 2 arguments, it applies the 2 outer ones and then gives their outputs into the inner one. So if you have plus times plus, then it will add them both and then multiply the result, which makes sense because you go, well, yeah, I'm plussing on the left, I'm plussing on the right, so I'm going to multiply them together. So it's not only simple in the concept of the patterns, but also intuitive in how the patterns are applied.
I have found your Hatred Hatred GitHub repo and the description, a programming language where no command does what you want it to.
Yes. I believe the GitHub repo is quite out of date, and the my local copy actually has more development on it. But I just ended up with the pattern matching on GitHub, if I remember correctly.
Interesting. So, I mean, a side question: you've mentioned now Hatred, Gelatin, and we've mentioned Jam, and we should spend some time talking about that as well. So how many programming languages have you created in total, and how many are available online for people to look at?
That is a very good question. I have lost count.
Oh, wow. So we're talking double digits then, at least.
Oh, we're talking 20 plus. Yeah.
Okay.
It honestly, if you look at my GitHub, basically it's all just different languages. I could talk for a while about my different languages, but that's not the point. Is because I like to sort of do them as a proof of concept thing of, that would be a neat idea of passing instructions between each other or data representation or something like that, and then just build it until it seems like a coherent model. And none of them are groundbreaking or anything, but they're fun proof of concepts most of the time. The one I was really happy with is called Add++, which is one of my first ones that I made. Raise Time actually helped me develop that and wrote the wiki for that. yeah, far-reaching impact. Sorry, yeah. But Add++, I then managed to write an interpreter for another language in that and prove that the language Add++ was interpreting was Turing complete. So managed to write an interpreter for a Turing complete language in one of my own languages, which was a neat proof of concept exercise. Yeah. So they're languages in the sense that they are interpreters for proof of concepts.
We did mention a jam as well, and that we should spend some time. So, tell us how similar it is to Jelly. Obviously, it's a fork, so it has a lot of the same stuff. But what have you done to extend or make the language different?
So I do actually need to correct you on Jam. Jam, I haven't really been working on Jam for about a couple of years now. Real life stuff happened, so it never came out as a finished product. I am planning on finishing at some point. It originated from a fork of Jelly, and is my attempt to update Jelly with, we've been using it for 8 years now. We know what a lot of the mistakes that were made in the original design were, where 2-byte commands have been used that should be 1 bytes because they're used all the time and it's just wasting. I mean, famously on CoGolf, there was a challenge where an APL answer beat a Jelly answer because APL has lowest common multiple as a single byte built-in, whereas Jelly has it as 2 bytes. And so I believe it was one of Adam's answers, actually, beating Jelly with APL. And it's one of these things where there are lots of flaws in this language. I would love to update them, correct them. The pattern matching is actually one of the only things I haven't touched because it was done perfectly first time. I couldn't improve on it if I tried. But the big ones are behavior of atoms, new quicks, new features, that kind of stuff. And I wrote up a solid amount of it, and then real life stuff happened. I went to university, and that took up a substantial portion of my free time. whereas whereas Jam was first developed during the pandemic, just after I left high school, and had all of the free time in the world to work on this thing that I wanted to work on. And then real life happened, and it kind of got relegated. The biggest thing that stopped it was just adding in all of the commands. I think I wrote up a list of about 500 different primitives that I wanted to add in, and understandably, that takes a long time to actually implement. But the usable thing for Jam now is the Jelly fork, because that was effectively the alpha version of Jam. My aim for that fork was to update Jelly to be more competitive years after it's stopped being updated, but still keeping backwards compatibility with the actual Jelly. Like the fork is a fork of the language. It's not a new language itself.
I see.
But most of the commands that I added into that fork, I have either brought in or I intend to bring into Jam. And at some point, I will finally finish off Jam and publish it. And I can see just how well it compares against Jelly. But yeah, I feel a little bad that I was invited on to talk about an unfinished project of mine.
But so all these forks, have you considered using a spoon?
I don't know. I like stabbing things,
Even if they're jelly?
Yeah. Have you never tried eating jelly with a fork?
I suppose not.
Come on, Marshall. You're one of those Arabian language people that likes forks.
Yeah.
Well, they have their uses.
The big thing is sort of the improvements on jelly that I decided to go, it's been long enough. The creator is no longer updating the language. I would like to add in my own updates. And it's had some use, especially in CoGolf. I've beaten quite a lot of my own jelly answers by 3 or 4 bytes. The first time it was used, I improved a 7-byte jelly answer down into 5 bytes using my fork, just with one command that I added, because the thing it replaces, effectively it's a operator that takes a command and uses keep those for which the following equals the right-hand value. So, if you have a list of lists and you want to keep those with a specific sum, then you just do this with the sum and then the sum on the right-hand side. So you want to keep those that sum to 5, you just do sum, keep command 5. And in normal Jelly, it's like 5 bytes to do that and it's a very common thing. And in golfing, save every byte that you can. Code golfing specifically.
A bit of context there as well for the non-code golf listener. You mentioned like 3-4 bytes, and most people writing computer programs, they don't think of 3-4 bytes as a whole lot. They usually measure the code in, I don't know, millions of lines of source code or something like that.
Yes.
But for code golf, it's a big thing, and it's perfectly acceptable to be able to save 1 byte on, say, like a 20-byte program, even if that means that there will be the heat death of the universe before it finishes. 'Cause, I mean, theoretically, it will finish, right?
Yeah, I believe a couple of years ago, on one of the categories in our best of this year stuff was biggest answers, by which I mean takes the longest to finish. Because some of my Jelly programs, in the effort of saving 1 or 2 bytes, had complexities of O2 to the n factorial, or O n to the 9 to the n. Because it's 2 bytes. I've got to save those 2 bytes.
For anyone that hasn't tried code golfing, it may sound like it's an odd hobby, but it is. Or maybe I just have a similar brain to yours, Jay, in that the same itch is scratched. But it is it forces you to bend your mind in a way that no other problem does. Because how often are you trying to do, like, your sole goal is just shaving off characters or bytes, and
it's a very old sport, I can tell you. I have I'm good on authority from my father, who worked at IBM. I think it was from 68 to 72, and they were doing code golf, sometimes out of necessity.
Yeah.
Because the computer simply couldn't contain large code. They could spend more time but not have more memory, and they would do things like come and present some programs, say if anybody can shave off 1 whatever code unit they were using at the time, maybe not a byte, and then they would give them a cup of coffee. And he even told me about a problem he was given. He was informally known as the Department for Seemingly Unsolvable Problems, and from IBM International. So people around the world couldn't solve a problem, they would send it to him, and he was always worried that he would get fired because it was so hard for him to do his job. But one of the problems that he got this way was implementing some translation table between 2 things in as part of a larger system that was already filling the computer's capabilities. So there wasn't enough space to have the 2 tables, so the lookup table and the corresponding result table. And he solved it by looking at the commonalities between these 2 tables, and then only translating those parts that were actually different or couldn't, with some formula, compute what the other one would be. Maybe I don't know what it was. Maybe it was like the alphabet, and the alphabet is in the same order, but in a different place, or partially in the same order, those kind of things. So I had to use code golf methods, this kind of ridiculous code, in order to shave a little bit off and made it run. And he got in trouble because one of the code pages or whatever it was, one of these tables was proprietary, and they weren't allowed to change it. And, just have to say, do you want to keep the rules, or you want the program to run?
Yeah, I have actually written up a fairly long and detailed history of Code Golf post, because it originates, as Adam says, back when it was a necessity, and then died out until the early 2000s when Perl Golf exploded onto the scene when Stack Overflow was created. There was a bunch of people who just went, hey, let's do Code Golf on this and do it in Perl, because apparently it looks incomprehensible, and APL used to be considered cheating because it wasn't real code and you're making up symbols for it and all this. And then there was the very first golfing specific language created called GolfScript back in 2008. and it's slow and clunky and horribly verbose now compared to the 5 or 6 byte answers that you get in modern Code Golf. But I've done a complete breakdown of it. It's a topic that I very, very much enjoy talking about. As in case you couldn't tell.
Hey, I did code. You said in the early 2000s. I did Code Golf in I think it was 97, the age 12, and I was in the home of Anthony Camacho, who's an APLer, and I think developer or leader of the IAPL project that never really went anywhere. And I was there with my father, and there was this traditional simple ON squared way of getting prime numbers in APL, and everybody was using the same exact formulation, and I came up with a shorter way to formulate it, and my father and Anthony Camacho, they were all like up in arms about this, like, whoa, he beat the record. This is we have to revise the books now. This is a shorter way of getting prime numbers in APL. So it was definitely a known thing to them in the APL community.
Well, I mean, especially in languages like APL, JK, where you can write incredibly short code and it still does, the same thing at not an unreasonably complex process. Like you're not shaving off every byte you can, but occasional quick APL train. Why write out the full variables and assign it when you can do it in 8 or 9 characters? Because that's all you need for a quick offhand script. It's completely valid. And Code Golf just went, hey, watch me try and make this into a sport for fun rather than just a necessity, and we can do this.
Yeah, so I have Dijkstra complaining about in 1972. He says, the first thing a group of programmers end up doing when they get an APL terminal is they start, they start trying to solve problems in one line, and then they ask each other, can you solve it in fewer symbols? So
that's all that Dijkstra said.
thing.
I thought there was surely it was going to slam, if not APL, some programming language.
As if it had any conceptual relevance is his complaint.
There we go. Okay. I was like, that sounded almost neutral. Well, I was looking because I had put my audio Audacity recorder behind a screen, and then I looked at the time and saw, holy smokes, we've once again.
There's no hour mark in the rabbit hole.
Oh, there we go. A classic. Podcast gold from Marshall Lochbaum. There's no hour mark in the rabbit hole. But yeah, we'll be sure to add all the links in the show notes to all of the languages mentioned, and also to the history. And if you haven't tried it, whether it's Code.golf or one of the Stack Exchange sites, I think you mentioned another one, Adam, was Weak Golf or something like that.
It's not active anymore, unfortunately. I think it's closed down.
Yeah, and it would be neat to see. I think Code.golf, it has a super nice UI and ranking system. That like I love leaderboards and stuff like that. So like they should get on top of adding a language like Jelly, or even some of these newer languages like Vixel or Vixel. And yeah, Jay, you're gonna say something?
Yeah, I found the site I was thinking of. I think the oldest Code Golf website. It's called Anarchy Golf.
Anarchy Golf.
Yeah, and it doesn't do explanations. It's just, here's a problem, try and solve it. It has Jelly on it. It has 115 different languages.
Holy smokes.
Yeah, and that's been going on since, I believe, 2008.
Wow. We will leave a link in the show notes as well to this. Initially, when I clicked on the link, it said, not available. But then after showing that, like 2 seconds later, the site did load, but it's got a triangle with an exclamation mark in it that says, not secure. But yeah. This looks great. So yeah, links for everything will be in the show notes. Thank you so much, Jay, for coming on. This has been fantastic. And I guess, for folks that are looking to get into Jelly and Jam, what's your recommendation? Basically just doing what you did, go read the source code, suffer for 3 years, and then you're an expert?
Honestly, I would recommend you go onto Code Golf and you ping me, at Caird and say, I'm interested in learning Jelly, and I will happily teach people who want to learn Jelly.
Wow, look at that. Look at that. What an offer.
We have the chat room that was originally used. I would love to unfreeze it and go through them, because there's a bunch of learning resources on there, which I'll link for you so you can put it in the show notes.
Awesome, yeah.
On just beginner exercises and stuff like that on how to learn Jelly.
Fantastic. Yeah, we will be sure, as mentioned before, to add those to the links in the show notes. And yeah, what an offer. If you're listening to this and you're thinking, oh, this sounds tricky, well, you got a personal teacher waiting to teach you if you're interested. And yeah, I will throw it over to Bob, who...
Don't overwhelm me.
Don't worry. We've, I mean, actually, we do have the listeners in the hundreds.
Worry, but only a little bit.
Well, if you do want to get in touch with us, you can contact us at contact@arraycast.com, and we welcome your comments and questions and feedback. And shout out to our transcribers, Sanjay and Igor, who do a great job every episode putting this onto... and Adam as well, who does the initial transcription that gives us timestamps, which is wonderful. Thank you again to Adam. And during this episode, a number of times, references to Ray's Time have come up. And undoubtedly, if you're in this community, you will see that name pop up from time to time. And when you see it, just pause and reflect and be grateful for what he provided to us all. I think that's an important message going forward.
I think with that, we will say, happy array programming.
Happy array programming.